So next concept is about ideal pulley. Ideal pulley. Okay, write down. So ideal pulley means massless and frictionless. So ideal pulley means massless pulley and frictionless pulley. So massless pulley means the mass of the pulley is 0. If mass of the pulley is 0, then resultant force acting on the pulley. We know resultant force means mass into acceleration. So in the case of ideal pulley, it is massless pulley, mass 0 value. If mass is 0, no resultant force. So resultant force acting on the pulley also equal to 0. So that is the meaning of massless. So massless means mass of the pulley 0, no resultant force acting on the pulley 0. No resultant force acting on the pulley 0 means forces acting on the pulley, forces acting on the pulley or balanced. Forces acting on the pulley or balanced. That means, for example, we have a pulley. So in a question, for example, in a question we got, so it is the ideal pulley. If it is ideal pulley, in the question it is one force acting on the pulley F1. So on the pulley it is one force acting on the pulley, then after it is one force acting on the pulley. For example, I'm taking three forces acting on the ideal pulley. So ideal means massless means resultant force acting on the pulley 0. No, resultant force acting on the pulley 0 means forces will be balanced. So forces are balanced means upward forces balanced by downward forces. Upward forces balanced by downward forces. Then what is the force equation? We get it, that is F1 equal to F2 plus F3. So it is a meaning of massless pulley. The forces will be balanced. So upward forces acting on the pulley, so balanced with downward forces acting on the pulley. Yeah, please note down. So it is the first point. Now write down second point. Write down second point. So for example, in the case of pulley, write down there are three arms. There are three arms will decide. Three arms will decide motion of the pulley. There are three arms will decide motion of the pulley. So what are the three arms? So here in the case of pulley, it is one arm. It is one arm. So it is nothing but central arm. So it is central arm. This central arm is also known as main arm. is nothing but main arm. So in the case of pulley, there are totally three arms. Three arms will decide the motion of the pulley. So it is the first arm. It is central arm. This is central arm is nothing but main arm. Then after, so these two are nothing but hanging arms. Hanging arms. These hanging arms also nothing but side arms. Hanging arms also nothing but side arms. So therefore totally three arms. So it is the first one, central arm, and these two are side arms. Central one and these two are side arms. So these three arms will decide the motion of the pulley. So it is second point. Write down third point. So third point is the pulleys can be studied. The pulleys can be studied under three possible cases. Under three possible cases. Pulleys can be studied under three possible cases. Case 1. Case 1. Draw the figure. For example, it is support. It is support. And here it is the pulley. For this pulley, it is central arm. So here central arm is fixed. Central arm is fixed. Then after, these two are side arms. And here M1 block suspended from it. M1 block suspended from it. And here M2 block suspended from it. Now it is central arm and these two are side arms. From this side arm, M1 block suspended, and from this side arm, M2 block suspended. For example, let us assume that M1 is greater than M2. Let us assume that M1 greater than M2. That means M1 is heavier. If M1 is heavier, it moves downwards. If it is moving downwards, and M2 block will move upwards. M2 block will move upwards. If M1 block is moving downwards, M2 block will move upwards. That means in the first case, this main arm is fixed. Main arm is fixed, but the side arms are in motion. This is side arm moving downwards. This is side arm moving upwards. So in the first case, what type of motion of pulley we have? What type of motion of pulley? Write down. Main arm is fixed. Main arm is fixed, and side arms free to move. Side arms free to move. These arms are the strings only. These arms are strings only. Okay, correct. So main arm is fixed and side arms are free to move. If one side arm is moving downwards, second side arm will move upwards. So it is the first case. So in the question, in this whole chapter, always we consider ideal string, ideal pulley. In the question, it is mentioned or not mentioned. All these are ideal strings. No case, no other cases at all. Ideal pulley we follow, ideal string we have to follow. So it is the first case. Main arm is fixed and hanging arms, side arms are free to move. Now write down second case. Second case, first of all, I will draw the figure. So from the figure, let us see the motion. So it is a support. So it is a pulley. For example, it is a pulley A. Okay, pulley A and a block suspended from it. Then after, and here, another pulley B, another pulley B. One side arm is fixed. One side arm is fixed. And from the second side arm, okay, from the second side arm, a block is suspended. A block is suspended. Now, I want to know about pulley B. I want to know the motion about pulley B. So in the case of pulley B, so what type of motion it is? That is, you please have to explain. In this case, in the case of pulley B, now this is central arm is fixed or free to move. Free to move. Central arm is free to move. And one side arm? Fixed. Okay, one side arm is fixed. And second side arm? Free to move. So central arm free to move. One side arm is fixed and second side arm free to move. Okay, write down the point. So in the case of pulley B, so what are the points we have put down? The main arm is free to move. So in the case of pulley B, the main arm, the central arm is free to move. One side arm is fixed. One side arm is fixed and second side arm is free to move. Second side arm is free to move. So it is the second case. Side also here, the main arm is central arm free to move. One side arm fixed, second side arm free to move. Write down third case. In third case, I will draw the figure. So from the figure, so let us see the motion of the pulley. Okay. In third case, for example, it is horizontal surface. It is pulley and we have a block. So for example, you focus on this pulley A. You focus on this pulley A. So in this pulley A, so what type of motion? So which arm is moving or which arm is not moving? So we have to explain now. So in the case of pulley A, so what about the central arm, main arm? The central arm, main arm, free to move or fixed? The central arm.
Free to move.
It is free to move. Why? Because if the block is moving downwards, if the block will move downwards, now this central arm, main arm. Pranav, keep the mic off. So in the case of pulley A, the central arm, main arm is free to move. So because of the block, if it is moving downwards, so here the central arm is in motion. And what about side arms? Free to move. So in this case, central arm free to move, side arms also free to move. So all the three arms, free to move. Right on the point. So in the case of pulley E, all three arms are free to move. So therefore, the motion of the pulley can be studied in three cases. So these are the three cases. You refer the first case. In first case, central arm fixed. In first case, central arm fixed and side arms free to move. Second case. In second case, central arm free to move. One side arm is fixed. Second side arm free to move. In third case, so all the three arms free to move. Right on? Next concept. So it is about ideal pulley. So simply ideal pulley means we have to consider massless pulley. So for example, in the question, if mass of the pulley also given, in the question, mass of the pulley is given. So those type of questions, we will do it in the chapter rotational motion. So in the case of laws of motion chapter, always we consider massless pulley. If mass is given, so those type of questions will be done in the chapter rotational motion. So in the previous classes, I told you about three types of constraint motion. Okay, there are three types of constraint motion. First one is string constraint that we completed already. And the second one is pulley constraint. And third one is wedge constraint. String constraint, pulley constraint, wedge constraint. So string constraint already we completed in the last lecture. Now right on second category is pulley constraint. Pulley constraint. So in this whole chapter, if pulley is given, always we have to consider as ideal pulley. Even the string is given, and always we have to consider as ideal string. So always we have to assume as ideal pulley and ideal string. In the question, they don't mention. So even though they mentioned or not mentioned, automatically we have to assume as ideal string and ideal pulley. Okay. So what is the pulley constraint means? And in the case of ideal string, we know total length is always constant. In the case of ideal string, so total length is always constant. Okay. My question is, for example, I'm taking a pulley. So this pulley is moving up with velocity Vp. For example, pulley is moving up with velocity Vp, and these are the two side arms. For example, here mass M1, and for example here mass M2. Mass M1 and mass M2. Just to focus on the string. For example, from this point to this point, this length I'm taking, let it be x1. Okay, so from the pulley to the block, let it be x1. In the same way, So from this point to the block, this length of the string, let it be x2. This length of the string, let it be x2. Then after, so here this length of the string, that is pi r, and r means radius of the pulley. R means radius of the pulley. Okay, R means radius of the pulley. So totally here, it is one length of the string, it is length of the string, it is length of the string. Okay, so what is the total length of the string? Total length of the string. So here x1 plus pi r plus x2. So that is the total length of the string. So in the questions, we get 2 fixed pulleys, 3 fixed pulleys, n number of fixed pulleys. Okay, so we will do all variety of questions. Okay, so it's not mandatory that only one fixed pulley is present. So that is not the case. So n number of pulleys will be fixed, n number of pulleys will be free to move. Okay. Yeah. And then first point, total length of the string. Total length of the string. So total length of the string from this figure, that is equal to x1 plus x2 plus pi r. So it is a pi r only. So half of the perimeter. So pi r. So total is a 2 pi r. It is only half part. So pi r. So total length of the string is x1 plus pi r plus x2. But we know already, always we have, so we consider ideal string. Ideal string means total length of the string is always constant. For example, it is pulley A, it is pulley B. So total, in the case of ideal string, so the total length is always constant. So for example, here pulley is in motion. Pulley is in motion, and because of masses, so M1 mass of the block, M2 mass of the block. So here the masses also, they will move up and down. Okay, for example, one is heavier. For example, if one is heavier and one is lighter, the heavier one will move downwards and the lighter one will move upwards. Okay, so the question is, now you please say the answer. In this case, so if M1 is heavier, for example, if M1 is heavier and M2 is lighter, if M1 is heavier, it will move downwards and M2 will move upwards. Okay, that means here, in this case, X1, this length is constant or changes with the time because of motion of the block.
Changes.
Changes with time.
And what about X2?
Changes.
Changes with time.
Changes with time.
The length pi r,
Doesn't
Changes
change.
with time.
So
No,
constant,
fixed.
constant,
that is
Constant.
constant.
constant,
So
sir.
X1 value changes with the time, X2 value changes with the time, but the pi r, this pi r length will be constant. So therefore, by differentiating this equation with respect to time on both sides, differentiating this equation with respect to time, now what we get, dx1 upon dt plus dx2, please.
Sir, x1 increases with time and x2 decreases with time, no?
But so we cannot say now always m1 is heavier.
Yes, sir. In this case,
In this case, that is correct.
Okay,
but
sir,
generally here, first of all, I am writing the formula general derivation. In the general derivation, I will explain you. So when we have to follow positive sign, when we have to follow negative sign, I will explain. Okay.
Okay, sir. Okay, thank you.
Write down this differentiation with respect to time. So dx1 by dt plus dx2 by dt, and pi r is constant. If pi r is constant, its differentiation is
0.
zero. Equal to, so this is a total length always constant, so it's a differentiation also
Zero.
0. From this equation, dx1 by dt, dx1 upon dt equal to minus dx2 upon dt, dx1 by dt equal to minus dx2 by dt. So you please answer. Dx1 by dt means, so because of the motion of block A, so due to the motion of block A, x1 changing. So dx1 by dt means it explains you about velocity of block A or velocity of block B.
A.
So it is
A.
the velocity of block A, but with respect to pulley. Velocity of block A with respect to pulley. Why? Because x1 is measured from where? X1 is measured from the pulley, correct? X1. This x1 length we are measuring from the pulley to block A. X1 we are measuring from pulley to block A. Okay. So therefore, this velocity, so dx1 by dt is velocity of block A, but with respect to pulley, equal to minus. In the same way, what is the meaning of dx2 by dt? Velocity of block B, velocity of block B, but with respect to pulley. That implies, so here you follow relative motion concept. Now velocity of block A with respect to pulley, that means what we can write, VA minus VP. From relative motion concept, VA minus VP equal to minus of same thing, velocity of block B with respect to pulley. So what we can write, VB minus VP. Therefore, VA minus VP equal to, so you open the brackets with a negative sign. So we get minus VB, minus into minus, plus VP. So from this equation, it is VA. This minus VB becomes plus VB to left side. So minus VB to left side becomes plus VB equal to, on right hand side. So here we have VP and this
2
minus
VP.
VP, so totally 2 VP. Therefore, from this equation, VP equal to, so I want to find velocity of the pulley. Therefore, VP equal to, the final equation is VA plus VB upon 2. VA plus VB upon 2. So in the question, if velocities are given, so velocity of the pulley, velocity of block A, velocity of block B, if velocities are given, this equation we have to follow. If velocities are given, okay. For example, if this velocity you differentiate with respect to time, these velocities, if we differentiate,
Acceleration.
no, so this equation we can convert into acceleration. So what we get, acceleration of the pulley equal to acceleration of block A plus acceleration of block B upon 2. By differentiating with respect to time. So this equation, for example, by differentiating with respect to time, so dv by dt means acceleration, dv by dt also acceleration, dv by dt also acceleration. So we get this equation. Now see the question. In the question, velocities information are given. Okay, velocities information given. You follow this formula. In the question, if acceleration informations are given, so you follow this formula. I don't. Next point. So these two equations are applicable. Velocity of the pulley, acceleration of the pulley means these two equations are applicable in the case of movable pulley. Velocity of the pulley, acceleration of the pulley are given means, so these two equations are applicable in the case of movable pulley. For example, I'm taking a fixed pulley. So we are taking a fixed ideal pulley. So here the main arm is fixed. The main arm is fixed and these are the side arms. So it is block A and it is block B. Block A and block B. So in this case, you please answer. So here, in the case of fixed pulley, in this formula, so which term becomes 0?
VP.
VP. Okay, just a minute. Again, the person woke up to disturb. So in this case, in the case of fixed pulley, so here this pulley is fixed. So VP value 0 and AP value also 0. Right? In the case of fixed pulley, VP equal to 0 and acceleration of the pulley also equal to 0. If VP and AP become 0, now this equation becomes VA equal to minus VB. If VP value 0, you simplify it. Now we get VA equal to minus VB. Same thing here. Acceleration of the pulley 0. That means AA equal to minus AB. So what it means here, VA equal to minus VB means, so here, for example, if this block A is moving down, this block A is moving down, for example, with velocity of 10 meter per second. For example, block A is moving down with velocity of 10 meter per second. This equal to indicates the magnitude of velocities will be same. This equal to indicates if it is moving down. If it is moving down with a magnitude of velocity 10 meter per second, and this block will move up with same magnitude. This minus indicates in opposite direction. If one block is moving down, this minus indicates opposite direction. If one block is moving down, other block will move up with the same magnitude of velocity. So equal to indicates same magnitude of velocity in opposite direction. Same magnitude of velocity. If it is 10 meter per second, this block B also will move up with the same magnitude but in opposite direction. Okay, so this minus indicates opposite direction with the same magnitude of velocity. Same thing here also. So what is the magnitude of acceleration? Same but in opposite direction. If one block is moving down, now other block will move up with the same magnitude of acceleration but in opposite direction. Opposite direction means if one block is moving down, other block will move up with the same magnitude. Note down, in the case of fixed pulley, write down these points. And write down one thing here. Whenever we are following these equations, strictly follow proper sign conventions. Strictly follow proper sign conventions. Strictly follow proper sign conventions. Okay, that means upward motion as positive and downward motion as negative. So strictly we have to follow these sign conventions. So whenever this velocity formula or this acceleration formula we are following, so we have to follow strictly the proper sign conventions. So upward motion or upward velocity taken positive, downward velocity taken negative. Same thing here, rightwards positive and leftwards negative. So this type of sign conventions we have to follow. So keep this point in the mind. Why? Because we will do the applications, we will do the questions. In some questions it will be helpful. In the case of fixed pulley, if one arm is moving down, the other arm will move up with the same magnitude of velocity or same magnitude of acceleration. Okay, but in opposite direction. If one is moving downwards, other one will move upwards with the same magnitude, of velocity or same magnitude of acceleration. Write down first question. First question, for example, pulley is moving up with velocity of 20 meter per second, and here block A, and it is block B, block A and block B, and block A is moving down with 2 meter per second. Block A is moving down with 2 meter per second. Find the velocity of block B. Find the velocity of block B. Simply you follow this formula with the proper sign conventions. So VP, velocity of the pulley, plus 20. So because upward direction positive, so plus 20 equal to VA, velocity of the block A. So velocity of block A is given 2 meter per second, but downwards. So minus 2 meter per second plus VB upon 2. And simplify, we get VB equal to 42 meter per second. And we got positive sign. So positive sign indicates the block B will move upwards. Block B will move upwards with velocity of 42 meter per second. Write down second question. In second question, so pulley is moving up with velocity of 20 meter per second. And here, this side arm is fixed. And it is block. A. And we have to find velocity of block A. So in this case, in the case of pulley, it is central arm, it is A and it is B, but this side arm is fixed. So this side arm is fixed means, so what is the formula we have? VP equal to VA plus VB upon 2. VP equal to VA plus VB upon 2. So in this case, so A and B are the two side arms. But here this side arm is fixed. So in this equation, what we have to take, VB value is 0. It is fixed arm, it doesn't move. So VB value is 0. And let us do it. VP value plus 20 equal to VA, we are finding out, plus VB value. So this is the fixed arm. So VB value 0 upon 2. Therefore, we get VA equal to plus 40 meter per second. And we are getting positive means this block will move upwards. It will move upwards with a speed of 40 meter per second. So it is second question. Now write the third question. In third question, it is acceleration of the pulley. And here we have a block. So we have to find acceleration of this block. So if the pulley is moving to right side, if the pulley is moving to right side, for example, with acceleration of 5 meter per second square. Okay, pulley is moving to right side with acceleration of 5 meter per second square. Now we have to find acceleration of the block. And same process, but in this question, accelerations are given. So we have to follow acceleration formula. AP equal to AA plus AB upon 2. And what is the acceleration of the pulley? Plus 5. And I told you already, rightward direction is positive. Rightward direction is positive. So it is plus 5. But in the case of pulley, one side arm is fixed. In the case of pulley, one side arm is fixed. For example, this value is 0. Plus for second arm, so acceleration is A. For second arm, this block acceleration A upon 2. Therefore, by simplifying, we get A equal to plus 10 meter per second square. And we are getting positive means this block will move rightwards. This block will move rightwards with acceleration of 10 meter per second square. Okay, next question. In the next question, it is a fixed pulley. It is a fixed pulley. So keep the point in the mind. In the case of fixed pulley, okay, on both sides, same magnitude of velocity will be present, but in opposite direction. Okay, so you keep the point in the mind. So it is the fixed pulley, and in the question, and here it is pulley P1. It is pulley P1, and these two are the side arms. So here block A, and here block B, and here we have pulley P2. So it's the pulley P2. Same thing here. It is block C, and it is block D. Block D. And in the question, the information given is block B is moving downwards with a 4 meter per second, and block A also moving downwards with a 2 meter per second. In the question, block D is given, it is moving up with 6 meter per second. We have to find from this condition. From this condition, we have to find velocity of block C. We have to find velocity of block C. Okay, so first of all here, if we focus on this pulley P1, so VP1 equal to same thing VA plus VB upon 2. Therefore, velocity of pulley P1 equal to VA minus 2, okay, downwards negative, and VB also negative, minus 4 upon 2. So minus 2 minus 4 minus 6 upon 2. So therefore, VP1 equal to minus 3. So minus 3 meter per second means this pulley is moving down. This pulley P1 is moving down. This pulley P1 is moving down with magnitude of velocity 3 meter per second. So therefore, in the case of fixed pulley, one end is moving down. In the case of fixed pulley, one end is moving down with 3 meter per second. The other end will move up with the same magnitude of velocity. In the case of fixed pulley, if one end is, okay, see, one side is moving down with 3 meter per second. In the case of fixed pulley, the other side also moving up with the same magnitude of velocity. So therefore here, now this velocity of P2, this pulley velocity 3 meter per second. So velocity of P2 pulley 3 meter per second. So therefore I'm taking VP2. So for this pulley P2, so what are the two sides we have? One is VC plus VD upon 2. For this pulley P2, so the two sides are C and D blocks. And what is the velocity of P2? So it is upward direction 3 meter per second. So it is plus 3 equal to, so we are finding the value of VC plus and VD, and what is the VD value? Plus 6. So upward direction positive. So plus 6 upon 2. By simplifying, we get VC equal to 0. So in the case of fixed pulley, if one side is moving down, so other side will move up with the same magnitude of velocity. Okay, write down. Next question. So next question is, for example, it is inclined plane. Inclined plane. Here we have a pulley. So it is a fixed pulley. It is fixed pulley. So draw the figure. So it is a fixed pulley. This uppermost one is a fixed pulley. It is fixed pulley. In the question, it is given that this block is moving down with 10 meter per second. This block is moving down with 10 meter per second, and we have to find velocity of this block. We have to find its velocity. So this velocity of the block is given, and we have to find velocity of this block. For example, as per our convenience, I'm taking it is P1 pulley, it is P2, and it is P3. So it is a fixed pulley. So first of all, I'm starting from P1 pulley. So VP1 equal to, so VA plus VB upon 2. So what is the VA value? So one side is moving down. So VA value minus 10 plus VB, other side is fixed. For the pulley P1, so it is one side is moving down and other side is fixed, so 0 upon 2. Therefore, Vp1 equal to minus 5 meter per second. Minus means this P1 pulley is moving downwards. This P1 pulley is moving downwards with a speed of 5 meter per second. So P1 pulley is moving downwards with a speed of 5 meter per second. Then after, next coming to P2. So Vp2 equal to, in the case of pulley P2, we are finding its velocity. But for this pulley, one side is connected to P1 pulley. For this P2 pulley, one side. See here, for this P2 pulley, one side is moving down. One side is moving down, minus 5. For this P2 pulley, one side is moving down with a velocity of 5 meter per second, minus 5. Plus, for this P2 pulley, the second side is fixed. Second side is fixed, so 0 upon 2. By simplifying, we get Vp2 equal to minus 2.5. So 2.5 meter per second. This minus indicates this P2 pulley is moving downwards with 2.5 meter per second. Therefore, here, in the case of fixed pulley, here, one side is having velocity of 2.5 meter per second. So what about other side is the same magnitude of 2.5 meter per second. So it is a fixed pulley, same magnitude of velocity will be present. Therefore, for this pulley P3, the velocity is 2.5 meter per second. 2.5 meter per second. Therefore, I am taking Vp3 equal to, see here, in this case, in the case of third pulley, one side is fixed. So one side is fixed, so 0 plus other side is V upon 2. And what is the P3? So third pulley velocity is 2.5. So 2.5 meter per second. Therefore, we get 5 meter per second. And 5 meter per second means in what direction? Along the direction of 2.5 meter per second or opposite to this velocity? No, this velocity 5 meter per second is along the direction of 2.5 or opposite?
Along the direction.
Along the direction.
Correct. So this velocity is along the direction of 2.5 meter per second. Yeah, right on. Next question. So in the next question, it is a fixed pulley. It is a fixed pulley. Okay, draw the figure. So for example, I'm taking here, it is P1 pulley, for example, it is P2 pulley. It is a plank. it is a plank and it is the block. In the question, this plank is moving down. This plank is moving down with velocity of 20. Plank is moving down with velocity of 20 meter per second. We have to find velocity of the block. We have to find velocity of the block. So for example here, it is a plank, for example. Now this plank is moving down. This plank is moving down with velocity of 20 meter per second. That means each and every point. So each and every point of the plank also moving down with 20 meter per second. If a plank is moving down, if the plank is moving down with velocity of 20 meter per second, that means each and every point of the plank also moving down with 20 meter per second. If we follow this logic, see here, this end, so it is connected to pulley, and this also connected, sorry, it is connected to the plank, this also connected to the plank, and this also connected to the plank. If the plank is moving down, now this point also moving down with 20 meter per second. And if the plank is moving down, now this point also moving down with 20 meter per second. So this point also, so here if the plank is moving down, now this point also moving down with 20 meter per second. Therefore, first of all, you focus on this side. So here this point is moving down. So I told you already, in the case of ideal string, along the length of the string, okay, so this point of the string, moving downwards with 20 means, so here this also moving downwards with 20 meter per second. Okay, so this and this side is moving down with 20 meter per second. Okay, now I have a question for you. In this case, this side is moving down with 20 meter per second. Then what about this side?
Moving up with 20 meter per
About
second.
20 meter per
Upwards
second.
of 20 meter per second.
What?
Minus
Meter per second. Why? Because in the case of fixed pulley, the magnitude of velocity is same in opposite direction. Therefore here, so it is 20 meter per second means what is the velocity of P1 pulley?
so 20 meter.
20 meter per
20.
second.
So I'm
20.
taking VP1. Okay, velocity of P1. You please answer. For this P1 pulley, one side, so is moving with how much velocity?
20.
So
20
minus
meter per
20.
second.
Minus 20.
Minus 20.
Minus 20 downwards. Plus for P1 pulley, what is the other side is connected to P2? For P1 pulley, other side is connected to P2. So VP2 upon 2. But in the question, what is the VP1 velocity of P1 pulley is plus 20 or minus 20?
Plus
P1
20.
Plus 20.
and you simplify it.
Not 20 meters per second.
No, do it once again. Therefore, by simplifying, what we get, velocity of P2 pulley equal to 60. And positive sign or negative sign?
Positive.
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 So positive means P2 is moving. Upwards. Upwards with 60 meter per second. Then after, so I'm taking P2 pulley, this pulley. For this P2 pulley, see one side is, what is the velocity? For P2 pulley, one side, what is the velocity?
Minus 20 meter per second.
Minus 20 meter per second, plus other side, I don't know velocity, so plus V upon 2. But already we have P2 pulley velocity is 60. And you simplify, so what about V equal to what we get?
140.
140 meter per second with positive sign or negative sign?
Positive.
Positive.
Positive means this block is moving
Upward.
upwards with velocity of 140 meter per second. completed?
2
1
seconds.
minute.
Yes, sir.
Okay, right down. Next question. So what type of pulley? Fixed pulley or a movable pulley?
So
It is
fixed.
fixed. And in the question, it is given block A. Okay, draw the figure. So in the question, block A moving down with 1 meter per second, and the block B is moving up with 2 meter per second. For example, let us assume it is P1 pulley. And these two are what type of pulleys? Fixed pulleys. These two are fixed pulleys. And a P1 pulley is the movable pulley. Now we have to find velocity of block C. We have to find velocity of block C. Okay, so in the case of fixed
Sir, all are
pulley,
movable.
these two are fixed pulleys now.
Sorry, sir.
Okay, so it is a movable pulley. Okay, so it is a fixed pulley. For this fixed pulley, one side is moving down, correct? One side is moving down with how much velocity? This side is moving down with how much velocity?
So 1 meter per second.
1 meter per second. So in the case of fixed pulley, if it is moving down, no other side will move,
Moving up with 1 meter per
moving up
second.
with 1 meter per second. And I don't know it is moving up or moving down, I don't know, but it's a velocity, let it be x. Let it be x. For example, if you get x value positive, means moving up. If you get x value negative, moving down. Okay, but this side arm, okay, this is side arm velocity, let it be x. Now you please answer. So here block B is moving upwards 2 meter per second. So if any block is moving, okay, for example, if a block is moving with some velocity, now each and every point of the block also possess the same magnitude of velocity in the same direction, correct? If the block is moving up. So this block is moving up with a 2 meter per second. So each and every point of the block also moving up with a 2 meter per second. So even this point also moving up. This point is moving up with a 2 meter per second. If it is moving up with a 2 meter per second, then this point is connected to string. So string also moving up. String also moving up with how much magnitude of velocity?
2 meter per second.
2 meter per second. So it is 2 meter per second. Therefore, I'm taking VP1. This is a pulley VP1. So for this a pulley, these two are the side arms. For this a P1 pulley, these two are the side arms. One side arm, what is the velocity? +1 or -1?
Plus one.
Plus 1.
+1. And the other side, I don't know, let it be x. Let us simplify it upon 2. And what is the VP1? This is a P1 pulley velocity is +2.
of C is -5.
Sorry,
So
Velocity of
3
C is
meters per second.
-5.
3 meter per second, correct answer.
Minus का sir, minus 3.
Ah, okay. So therefore, by simplifying, we get x equal to, okay, 3 meter per second. X equal to plus 3 meter per second means, no, this side arm is moving up or moving down.
Up.
So moving up
Up.
with how much magnitude of velocity is 3 meter per second. And it is a fixed pulley. In the case of fixed pulley, one arm is moving up. In the case of fixed pulley, so one side arm is moving up with 3 meter per second. The second arm will move down with the same
3 meters.
magnitude of velocity. Now this arm is moving down with 3 meter per second. That means what about block C also moving down with 3 meter per second. So therefore, block C velocity is 3 meter per second downwards. Right now. Next question. So it is the fixed pulley under block A. This block A is moving down with 4 meter per second. So it is movable pulley, and again it is fixed pulley. It is block C. It is block B. And in the question, this block B is moving down with 1 meter per second. Block B is moving down with 1 meter per second. You find out velocity of the block C. We have to find velocity of block C. Same thing here, it is fixed pulley, it is fixed pulley, it is fixed pulley. So in the case of fixed pulley, see, one side is moving down. In the case of fixed pulley, one side is moving down with 4 meter per second. If it is moving down with 4 meter per second, other side will move up. Will move up with 4 meter per second. Fixed pulley, one side is moving down with 4, other side will move up with 4. For example, it is P1 pulley and this is P2 pulley. So here block B is moving down. That means this point is moving down with 1 meter per second, and this point also moving down with 1 meter per second. So it is moving down with 1 meter per second, and this point also moving down with 1 meter per second. So now I'm taking P1 pulley, so VP1. VP1, in the case of P1 pulley, for example here, so this velocity, let it be x, we don't know, let it be x. So P1, so you consider P1 pulley. For this P1 pulley, see, one side is moving up, so +4, plus other side, we don't know, let it be x upon 2. And what is the VP1 velocity? You please answer. VP1 velocity?
1.
1 minus 1.
-1. It is -1. Therefore, by simplifying, what we get, x value is
Minus 6.
-6. X value -6 means now this side arm is moving up or moving down.
Down.
So moving down with 6 meter per second. Moving down with 6 meter per second. Again, it is a fixed pulley. So it is a fixed pulley. One side is moving down one side is moving down with 6 meter per second, other side will move up with 6 meter per second. So it is a fixed pulley, one side is moving down with 6 meter per second, other side will move up with 6 meter per second. Now you consider, so P2 second pulley, VP2 equal to, so in the case of the second pulley P2, see one arm is moving up, so plus 6, plus I don't know its velocity, let it be y.
The
So
velocity of C 8 meters per second upwards, no?
8 meter per second upwards.
Yes, sir.
Okay. So in the case of P2, so second pulley, one side is plus 6 and other side is y velocity. And what is the P2 pulley velocity is plus 1 or minus 1?
-1.
Minus 1. Therefore, by simplifying, what we get, y value
-8.
is minus 8. Okay, minus 8 means this arm is moving down. Moving down with 8 meter per second. Same thing, it is a fixed pulley. If it is a fixed pulley, so one side is moving down with 8 meter per second, moving down with 8 meter per second, other side will move up with 8 meter per second. Therefore, now this arm is moving up with 8 meter per second, that is block C also moving up with a magnitude of velocity 8 meter per second. So it is about pulley constraint.
So pulley constraint is over.
It is over.
Okay, sir.
Right, next concept.
Sir, just
Wait.
1 minute, please.
Okay. Done.
Yes, sir.
So is it clear? Pulley constraint, finding velocities, accelerations, everything. Right on. Next concept. Motion of pulley block system. Pulley block system. Right on. First question. In this concept, right on, first question, very basic one. So it is a support, and here it is a pulley, fixed pulley. It is fixed pulley, and here block M1, and this is block M2. It is block M2. Let us assume that M1 is greater than M2. So M1 mass is heavier. M1 is greater than M2. If M1 is greater, this block will move downwards with acceleration A. M1 block will move downwards with acceleration A. So it is a fixed pulley, means one side is moving down with acceleration A, the other side will move up with the same magnitude of acceleration. In the case of fixed pulley, same magnitude of acceleration in opposite direction. Now we have to find the acceleration. We have to find the acceleration in the same way. So here M1 and M2 blocks, M1, M2 blocks are connected by ideal string. M1, M2 blocks are connected by ideal string. You please answer, in the case of ideal string, means massless string. So what is the tension force at all points will be? Constant, same. So here M1, M2 are connected by ideal string, means massless string. So tension force at all points is same. So for example, the tension force is, let it be T. Tension force in the string, let it be T, T value we have to find out. So totally we have two questions. So we have to find the acceleration and we have to find the tension force in the same way. And this is a different string. Okay, another string. It is a string, for example, tension force T dash. It is another string. It is a string tension force T dash. So we have to find the acceleration, we have to find a T tension force, and we have to find a T dash tension force. Okay, let us see free body diagram. You please answer. For the block M1, weight M1 G downwards. Weight M1 G downwards. I have a question. What is the direction of tension force?
Upwards.
Direction
Away from the body.
away from the body along the string. If this is the body I'm taking, M1 is the body I'm taking, so what is the direction of tension force is?
Upward.
Away,
Upwards.
away from the body along the string. In the same way, for the block M2, so weight is M2G and direction downwards. In the same way, if this is the body M2 we are taking, body M2 we are taking, so what is the direction of tension force is?
Downwards.
Upwards.
Upwards. So it is the direction of tension force. So downwards, do we have any string? Downwards, do we have any string?
No.
No, sir.
So what is the direction of tension force away from the body? Away from the body along the string. Okay. Then after, one more important one. If this is the body I'm taking, if this is the body I'm taking, for this body, what is the direction of tension force this side? If this is the body I'm taking, if this is the body I'm taking, so for this body, what is the direction of tension force here? Upwards.
Downwards.
Perfect. Downwards. Why? Because here, if this is the body, what is the direction of tension force away from the body? Away from the body along the string. Away from the body along the string. Same thing, if this is the body I'm taking, if this is the body I'm taking, so this side, what is the direction of tension force?
Downwards.
Downwards again.
Downwards again. Perfect. Then after, this is the body I'm taking. If this is the body I'm taking, so in this string, what is the direction of T dash tension force? If this is the body,
Upwards.
Upwards.
upwards. Perfect. And what type of pulley it is?
Fixed.
Okay, a fixed pulley. Okay,
pulley.
ideal pulley. Ideal pulley. So what is the meaning of ideal pulley? Massless pulley. In the case of massless pulley, what is the resultant force acting on the pulley is?
0.
0.
Zero. If resultant force acting on the pulley 0 means this upward force balanced by downward force. Therefore, T dash is equal to T
2 times
or
T.
2T.
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 2T. Perfect. So T dash equal to 2T. So if we calculate T value, so we can also find out T dash value. Okay. Is it clear? The free body diagram. The only thing is we have to understand the direction of tension force away from the body along the string. Now the question is, if we consider the block M1, I'm taking block. So first of all, the first case I'm doing in detailed. Then after, so I will say the short trick to find the acceleration. If you know short trick, so we can find out acceleration. So within seconds. Okay. So first of all, I'm taking the block M1. You please answer. In the case of block M1, so how many forces are present along the direction of motion? On block M1, so two forces. And the two forces in the same direction, in opposite direction.
Opposite direction.
Opposite.
Then how to find the resultant force? Subtraction, but T minus M1G or M1G minus
M1G minus G.
M1G
minus
minus
T.
T.
M1G minus T. The resultant force means mass M1 into acceleration A. So M1 A equal to M1G minus T. Let it be first equation. So it is a dynamic equation for the block M1. Next, we are taking the block M2. Same thing here. Along the direction of motion on the block M2. On the block M2, there are totally two forces are acting. And both forces in opposite direction. Therefore, what is the dynamic equation resulting to force equal to what we get?
T minus
T
M.
T
minus
minus
M2G.
M2G.
T minus m2g, and resultant force means mass into acceleration, that is m2a, equal to T minus m2g. Let it be second equation. Now do one thing. So equation 1 plus equation 2. So addition of both equations 1 and 2. So see left side addition. In left side addition, m1a plus m2a. m1a plus m2a. So you take a is the common. If a is the common, we get in bracket m1 plus m2. m1a plus m2a. So a is the common, in bracket we have m1 plus m2 equal to, see on right hand side addition. So it is minus t, it is plus t, they cancel out. In the addition of equations 1 and 2, this minus t and the plus t cancel out. So after cancellation, what we left with on right hand side, it is m1g plus m2g or minus m2g after cancellation,
Minus M2G.
minus m2g. So therefore, a into m1 plus m2, on right hand side, you take g common, so m1 minus m2 into g. Therefore, we have to find the acceleration. We get that is m1 minus m2 into g upon m1 plus m2. It is about acceleration of each block. So first question completed, finding acceleration completed. Next we have to find a T tension force. Next we have to find a T dash tension force. So in this question, there is no new point. The only thing is mathematics. The simplification, we have to do it. Write down. So for M1 block, okay, according to free body diagram, dynamic equation. For M2 block, according to free body diagram, dynamic equations. Then after addition and simplification.
Sir, we can use a short trick for acceleration, right? Like,
I will explain you. So we cannot expect always this type of system. Okay, so it changes. I will see the short trick. Then
2 seconds. So,
please.
so in the diagram, like the T's which you have represented with blue and the ones which you have represented with black have same magnitude, right?
Same magnitude.
Okay, sir. Thank you.
It is an ideal string now.
Yes, sir.
In the
That's
case
why
of
I'm
ideal, only directions will be different with respect to different bodies. But what is the magnitude? The
It's the
magnitude
same,
will
right?
be same.
Okay,
It's
sir. Thank you. So signs different, magnitude is same.
perfect.
Thank you.
Done, sir.
Okay. Now we have to find out T tension force. Listen. For example, you refer the first equation. What is the first equation? We have m1a equal to m1g minus t. So it is the first equation. From this equation, T tension force equal to, we get m1g minus m1a. So therefore, T tension force equal to m1g minus, again m1 into, in the place of acceleration, we are writing this formula. So what we get, that is m1 minus m2 into g upon m1 plus m2. So m1g as it is minus m1 into, in the place of acceleration, we are writing this equation. Therefore, T equal to, see here, in both the terms, I'm taking m1g is the common. In both the terms, I'm taking M1G is the common. So M1G already common. So we have 1 minus. So here we have M1 and G. So M1G already common. M1G already common. So what we left with, it is M1 minus M2 upon, in denominator, M1 plus M2. And we have to take the LCM and simplification. Therefore, T equal to M1G. Now in the box, so you take the LCM. Now this part is M1 plus M2. M1 plus M2. Then after you open this bracket with a negative sign. You open this bracket with a negative sign, that is minus M1, minus into minus plus M2 whole upon, and whatever denominator LCM is M1 plus M2. Denominator LCM M1 plus M2. Therefore, T equal to, here we have M1G outside. So plus M1 minus M1 cancel out. So M1 cancel out. So numerator 2M2, numerator 2M2, in denominator M1 plus M2. Therefore, the final equation is T equal to, see numerator completely, that is 2 M1 M2 G, numerator completely 2 M1 M2 G upon denominator M1 plus M2. It is about tension force in the string T value. If we know T value, so we can find out T dash also. So therefore T dash equal to 2 times.
2 times.
So we get totally 4 M1 M2 G upon M1 plus M2. So this is the question, finding acceleration and finding tension forces.
So, like these are
Please.
formulas for like only this case, right?
Only this case.
Okay, sir. So we
This-
need not learn this, right?
No need.
We
No
just
need.
understand this, right? How we derive it.
Just see the procedure. That's it.
Okay, sir.
Sir, can you explain the diagram again?
So what is the direction of tension force?
Upward.
Don't say upwards. What is the statement I have given? Tension force always upwards. That is the statement I have given.
Along the string.
Along
Away
the
from
string.
the body along the string.
From the body.
Away from the body along the string. So whatever the body, okay, you are considering away from the body along the string. If this is the body, we are taking away from the body along the string. If this is the body, we are taking away from the body along the string. If this is the body, we are taking away from the body, okay, away from the body along the string, away from the body along the string, away from the body along the string. So don't by heart tension force upwards. That is wrong. What is the direction of tension force? Away from the body along the string.
Sir,
Please.
can you please explain how you wrote T dash is equal to 2T?
So what type of pulley it is? Ideal, correct?
Yes, sir.
What is the property of ideal pulley? Massless.
Yes, sir.
So ideal pulley means massless pulley. If mass 0, no resultant force acting on the pulley is
0.
So resultant force 0 means the forces are balanced. Correct? That means upward forces balanced by downward forces. So therefore on the pulley in upward direction, how many forces on the pulley? In upward direction, how many forces acting? Only one, T dash. But on the pulley in downward direction, how many forces acting?
2 forces.
2 forces. And it is an ideal pulley, massless pulley, resultant force 0 means forces are balanced. Forces are balanced means upward force balanced by downward force.
Okay,
therefore
sir.
T dash is balanced with 2T. Okay.
2T.
Completed?
Yes, sir.
Okay.
Sir, what is away from the body along the string?
tension force direction, man. Right on, second question. For example, it is a fixed pulley, and here it is a block M1, it is a block M2, then after it is a block M3, block M3. Okay, just imagine that, for example, if M1 is moving down with acceleration E, M1 is, sorry, M3 is moving down with acceleration E, then what about M2 block? If M3 block moving down with acceleration
M2
E,
block moving with acceleration.
Down.
okay, with same acceleration, with a different acceleration.
Same.
Same.
Then after, if M2 block is moving downwards, that means this side arm moving downwards. M2 block is moving downwards. This side arm is moving downwards with acceleration E. If this side arm is moving downwards, or this side arm is moving
Upwards.
upwards with the same magnitude of acceleration. So here
So here
M1,
M3 plus M2 is greater than M1.
correct.
Okay.
Therefore, here M1, M2 are connected by a string. M1, M2 are connected by a string. So in this string, what is the tension force at all points will be same. For example, this tension force I'm taking, let it be T1. In this string, tension force, let it be T1. And in this string, tension force, for example, let it be T2. Now we have to find the acceleration T1 and T2. So no need of in detailed simplification, just we see the process. Why? Because rest of the things are simply mathematics, we will do it. The only
Your
thing is,
acceleration would be G in bracket M3 plus M2 minus M1 by M1 plus M2 plus M3.
correct. So listen, the short trick is, so first of all here, in the case of M3 block, what is the weight M3G and what is the direction downwards? So it's the weight downwards, M2G weight downwards, M1G weight downwards. Is it clear? Now I'm writing the short trick. No need of in detailed simplification. Simply see the short trick. The short trick is, so here M3 is moving downwards, M2 is moving downwards, M1 is moving upwards. So here all are moving in vertical direction, maybe vertically upwards or downwards, but all the motions are present in the vertical direction, correct? All the motions are present in the vertical direction. The short trick is, so to find the acceleration, along the direction of motion, so what are the weights are present, weights or weight components? Okay, so weight or weight components we have to consider, that's it. Along the, so to find the acceleration along the direction of motion, if any weights or weight components are present, those we have to consider. Okay, write down the point. To find acceleration along the direction of motion, weights or weight components. Okay, in some cases we get mg cos theta, mg sin theta. So weight components will get it in some questions. So weights or weight components should be considered. So therefore acceleration equal to, see here, starting from M3. Now M3 is moving downwards. So along the direction of motion, its weight is present or not present?
So present.
Its weight is present. So M3G we have to consider. Okay, but this weight is present in the same direction of motion or in opposite direction of motion?
The same
Same.
direction of motion.
Same direction of motion, take positive. Take positive. So first of all, see the direction of motion. Along the direction of motion, so weight is present or not present, you identify. Along the direction of motion, if weight is present, you consider. So in this case, along the direction of motion, weight is present. So we have to consider M3G. But this M3G weight is present along the direction of motion. See, the direction of M3G is along the direction of motion. So take positive. So coming to M2 block. For M2 block, along the direction of motion. So what is the direction of motion? Vertical. Okay. Along the direction of motion, its weight is present or not present?
Present.
Present.
M2G we have to consider. Okay, M2G we have to consider, but this M2G is a positive or negative?
Negative.
Positive.
Positive. Why positive here?
So along
This
the
M2
direction of motion.
along the direction of motion. This M2G present along the direction of motion. So plus M2G. Then after, so coming to the block M1. So this block is in the vertical direction. The motion in the vertical direction. Now in the vertical direction, weight is present or not present? This
Present.
block is moving vertical in vertical direction. So here in a vertical direction, weight is present. So M1G we have to consider or not necessary?
We have to consider.
So minus
We have to-
M1G.
Minus
Correct.
M1G.
We have to consider, but this M1G present along the direction of motion or opposite to direction of motion?
Opposite.
So opposite. So minus M1G. Upon in denominator always we have to write sum of all the masses, summation of all the masses. It is about acceleration, finding acceleration. The only thing is along the direction of motion, if weights or weight components are present, we have to consider. But when we have to follow positive sign and when we have to follow negative sign, if weight is present along the direction of motion, positive. If weight is present opposite to direction of motion, is negative. Now, is it clear, this process? Is it clear, finding acceleration?
Sir, can you
Yes,
explain again?
So what is it, where you are getting difficulty? Let me know, then I will explain accordingly. Is it clear how M3G positive?
Minus M1G.
See, in this case, this M1 block is moving horizontally or vertically? See, vertically, upward or
Vertically.
downward, leave it. But this M1 block is moving vertically. Okay.
Yes.
So in vertical direction, weight is present, not present.
Not present.
This weight is present in the horizontal direction.
No.
This weight is present in the vertical direction, in the horizontal direction.
Vertical direction.
It is a vertical motion or horizontal motion?
Vertical motion.
It is a vertical motion, and this weight also present in the vertical direction. Correct?
Yes.
So here it is vertical, and this also in vertical.
Yes.
So therefore M1G we have to consider or not?
Not.
So here, do you know at least the meaning of horizontal and vertical? You know the meanings? Geet. Again, he was absent. Okay, remaining people, is it clear? Why negative M1G?
Yes, sir.
Yes, sir.
Yes, sir.
See here, M1 block, the motion is vertical motion. Vertical motion and weight also present in the vertical direction. Vertical motion, weight also present in the vertical direction. So that means along the direction of motion, weight is present in a vertical direction. In a vertical direction, weight is present. We have to consider. But this weight is present along the direction of motion or opposite to direction of motion.
Opposite to direction of motion.
Opposite means minus M1G. So at least we are unable to identify what is the vertical, what is the horizontal. Then how you can understand physics? So we don't know vertical directions, we don't know horizontal directions, and we unable to identify what are the vertical forces. And we want 100% marks.
Sir, I have
Please.
a doubt. Here you said that the direction is vertical. That I understood. Are we, when we are considering this direction, we have to consider the direction of all three blocks or only one particular block at a time?
All three blocks. For example, here you see here this weight is present along the direction of motion.
Yes.
M3G we have to
Yes.
consider, and so M2G we have to consider, M1G we have to consider. But so positive, all values are positive or negative depends upon direction of motion. So
Yes.
along the direction of motion, this weight is present, positive. Along the direction of motion, this weight is present, positive. And this weight is present opposite to direction of motion, so negative.
Negative.
Yeah.
Is it possible that one block moves like vertical and other moves horizontal?
I will do it. I will do it.
Okay, okay.
Okay, so now we got acceleration, and what is the acceleration formula we have? M2G plus M3G minus M1G upon, in denominator, sum of the masses, M1 plus M2 plus M3. Now what is the process to find the T1 and T2 tension forces? So for example, if I take M1 block, if we take M1 block, so I will draw the free body diagram and dynamic equation. That's it. That is enough. In the case of M1 block, what is the weight direction?
Downwards.
Downward.
Downwards. Weight upward direction. So in the case of M1, weight is M1G, downward direction. So in the case of M1, which tension force acting? T1 tension force acting or T2 tension force acting?
T1.
T1. And what is the direction of T1 for the block M1?
Away from M1, that is upward.
Away from M1.
Away from M1 along the string. Away from M1 along the string.
Along the
So it is T1. And what is the direction of motion of the block M1? The block M1 is moving
Upwards.
upwards.
Along the
Therefore,
motion of tension force.
so therefore, what is the dynamic equation? What is the dynamic equation?
T1 minus
Resultant force
M1G.
equal to T1 minus M1G. Resultant force means mass into acceleration. That is M1A. Then after, so coming to second block M2. Now we are taking the block M2. So if M2 is the block mass, weight M2G, weight M2G. So on M2, only one tensional force acting or two tensional forces are acting? Two. Okay, why? Because this M2 block is connected to this string and also connected to this string. So on M2 block, totally two tensional forces are acting. Now with respect to M2, what is the direction of T1 tensional force in this string?
Upwards.
Upwards.
Then after, with respect to M2, what is the direction of tension force T2 in this string?
Downwards.
Downwards. So the thing is away from the block along the string. Yeah, Ria, is it clear?
Yes, sir. I knew this.
Then after, for the block M2, what is the direction of motion? It is moving downwards. Therefore, what is the dynamic equation of the block M2? Moving downwards.
M2G plus T2 minus T1.
Perfect. M2G plus T2, M2G plus T2, so minus T1. Resultant force means mass into acceleration. That is M2A. So already we have acceleration. So we can find out the T1 value, we can find out T2 value. In the same way, if we consider M3 block, on M3 block, how many tensional forces are acting? On M3 block, one, that is T1 or T2.
T2.
And what is the direction of T2?
Away from
Upwards.
the M3.
Away from the M3 means upwards or downwards?
Upward.
Upwards. Away from M3 along the string. So it is T2 tensional force. And the weight is M3G. And what is the direction of motion? Downwards. Therefore, what is the dynamic
M3G
equation?
minus
M3G
T2.
minus T2.
M3G minus T2. Resultant into force means mass into acceleration. M3E. Is it clear, the process? Yeah, write down. Third question.
Sir, so
Please.
by this, sir, by this M1, M2, and M3 equation that you have given, sir, even by using this, we can find acceleration, no?
Correct. For example, if we add all the three equations, by
Yes,
adding
sir.
all the three equations, we can find the acceleration that comes out same, M2G plus M3G
Yes, sir,
minus
the
M1G.
short trick that you gave.
Correct.
Okay, sir.
So,
Please.
so if we want to find T2, we can just use any one of the equations. Right?
Anyone, so you can follow second equation or third equation.
Or the third
That's
one,
up-
right? Okay, sir.
correct. That's
Thank
up to
you.
So for example here, this is the block M1. Okay, for example, I'm taking M1 block is moving down with acceleration A. M1 block moving down with acceleration A. And it is the block M2. It is the block M2 and this angle is given theta. So M1, M2 blocks are connected by a string. In this string, tension force, let it be T. If M1 is moving down, M1 is moving down with acceleration A, it is a fixed pulley. If M1 is moving down with acceleration A, now what about M2 block? Will move
Up with
the-
acceleration A.
Upwards.
Correct. So this block M2 will move up the inclined plane with the same magnitude of acceleration A. Now what is the short trick to find out acceleration? Listen, first of all here, in the case of M2, and already we done these components in the previous classes, we know weight always vertically downwards. Now you please answer, this component is cos theta component or sin theta component?
Cos.
Cos. So it is M2G cos theta. And what is the direction of M2G sin theta is down the inclined plane. Now it is M2G sin theta. In this case, the block M2 is moving upwards or moving horizontally or moving along the inclined plane. This block M2.
Along the inclined plane.
Along the inclined plane. So along the inclined plane, we have weight is present or weight component is present.
Component.
Weight component is present. Okay, this block M2 is moving along the inclined plane. This block M2 is moving along the inclined plane. So along the inclined plane, which component is present? Okay, weight component
Sin
M2G
theta.
sin theta. But this weight component is present along the direction of motion or opposite to direction
Away
of
from-
motion.
Opposite.
to direction of motion.
Therefore here, so write down acceleration equal to starting from M1. So this block is moving. So it is, we know weight M1G. But this M1G weight we have to consider or not? This
So could you please
M1G,
repeat?
this M1G weight we have to consider or not? Not necessary.
So
We
we need
have
to
to
consider.
We have
We
to
have
consider plus
Why?
M1.
Because here, correct, along the direction of motion, weight is present.
Yes,
So
sir.
along the direction of motion, weight is present, but positive M1G or negative M1G.
Positive.
Positive
Because it's
M1G.
along the acceleration.
Correct. Along the direction of motion, so positive M1G. Then after coming to second block M2, so this block M2 is moving along the inclined plane. It is moving along the inclined plane. Along the inclined plane, this weight component is present. So this weight component we have to consider. But this weight component is present along the direction of motion or opposite.
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 Minus
What we have?
MG2 sin theta.
Minus M2G sin theta. Upon in denominator, sum of the masses M1 plus M2. Now we got
Sir, we have
acceleration.
to consider that
Sir, but
component is in
M2G sin theta will be balanced by normal force, na?
M2G cos theta balanced by normal force. Okay.
Sir, we
M2G
only have
cos
to
theta.
consider that component which is in the direction of motion, no?
That's so what I told. Along the direction of motion, weights or weights components we have to consider.
Oh, yes,
No need
sir,
of others. Okay. Then we have to find tension force also. To find tension force, that's up to you. Taking block M1 or taking block M2, that's up to you. So for example here, with respect to M1, what is the direction of tension force?
Away. That is
Same is
upwards.
upwards.
Upward.
It is the direction of tension force. Then after, with respect to M2 block. So if it is the block I'm taking, if this is the body we are taking, so what is the direction of tension force? Away from the body along the string. So tension force is up the inclined plane or down the inclined plane?
Up the
Up the inclined plane.
Up the inclined plane. So therefore, in the case of M1, so what is the dynamic equation we get?
M1G minus T.
M1G minus T1.
So resultant force is M1G minus T. Resultant force M1G minus T. Resultant force means mass into acceleration. So M1A. Resultant force M1G minus T. Resultant force means mass into acceleration. In the same way, in the case of the block M2, so the block M2, what is the dynamic equation? It is moving up the inclined plane. Moving up the inclined plane. So what is the dynamic equation?
T minus MG.
T minus M2G sin
M2G.
theta.
T minus M2G sin theta. Equal to, so it is a resultant force. Resultant force means mass into acceleration. M2. Okay, just observe here, if we add both equations, minus T plus T cancel out. Now we have M1G minus M2G sin theta equal to M1 plus M2G.
We will get acceleration.
Got it now? Same equation will get it. Okay. Is it clear? Completed.
Done, sir.
Okay.
So can you give it in statement form, sir? Can you give the question in statement form?
No. So even in the question also they will give the figure and they say find acceleration or find tension force.
So the
That's
figure
it.
will be given in the question in JE also.
In JE also. Okay, they don't give the statement. Simply they draw the figure, find acceleration, find tension force in the string. That's it. Okay. Next one is, for example, it is inclined plane. We have a fixed pulley. So it is a block M2. And this also fixed pulley. So this is the block M1. Okay, you please answer, without any applied force, this block will come into motion? No.
No.
But this block can move?
Yes.
Yes.
Because of mg sin theta component.
Yes,
Because
sir.
of mg sin theta component, this block will move down. So here, this block is moving down the inclined plane with acceleration A. This block is moving down the inclined plane with acceleration A. If this block is moving down the inclined plane with acceleration A, now this block will move to right side to left side.
Left.
Side.
Left side. With the same acceleration, with a different acceleration.
Same acceleration.
Same acceleration.
Acceleration. Find acceleration. To find acceleration here, it is m2g, weight vertically downwards. Now this component is m2g cos theta or sin theta component. It is
Cos.
M2G
theta.
cos theta.
So it is m2g cos theta. Then after it is m2g sin theta. It is m2g sin theta. Then after, in this case, what is the weight direction?
Downwards.
Downwards. It is
Sir, can
M1.
we apply short trick?
We are doing it. Then after, with respect to M2, what is the direction of tension force? Okay, first of all, let us find acceleration. Any one of you. Just a guess. What is the acceleration formula?
Force applied upon mass.
Force applied upon mass. Okay. Then what is the force applied upon mass?
So
What is the force
M2g
applied?
sine theta minus
M2g sine
M1g
theta
upon
plus
M1 plus
M1g upon
M1.
M1 plus M2.
Okay. So M2g sine theta we have to consider or not?
So we have to
Yes, we have
consider.
to consider.
Positive or
Plus,
negative?
plus, positive.
Perfect. Perfect. M2g sine theta plus. Perfect. So coming to M1g, see here the motion is horizontal. The motion is horizontal, but weight is present vertical.
Downwards.
So motion is horizontal, weight is present vertical. That means do we have any weight? Okay, do we have any its weight present horizontally in the direction of motion?
No,
No.
sir.
Then
It is
don't take
balanced.
M1g.
Sir, it is balanced, right?
So
It
that
is
means
balanced
this
by normal
M1g.
force, right?
Okay, so that this M1g we have to consider or not?
No,
No.
sir.
No, sir.
No.
So simply M2g sine theta upon sum of
M1g.
masses. That's
M2.
it. Over. See, listen once again. This block is moving horizontally. The motion, horizontal motion. So in horizontal direction, no weight is present. Weight is present in the vertical direction, that is balanced by normal force. This weight is balanced by normal force. Okay. The motion is a horizontal motion. Motion is a horizontal motion, but weight is present vertical. So in the horizontal direction of motion, there is no weight. In the horizontal direction of motion, there is no weight. So don't consider M1g. That's it.
And sir, M1g is in rest, no?
It is at rest. No
Sir
tension
means,
force.
sir means
No
by
tension.
with respect
No
to
tension.
itself.
No, it is moving now. We are saying acceleration.
Sir, that I know, sir. It is it is actually in motion, sir. But there is no applied force on M. I'm asking like that. I'm sorry.
But the tension force present now.
Yes, sir.
So tension force is the driving force.
Okay.
Tension
sir,
force
I
is the
understand.
driving force. So because of tension force, driving force, it is moving with acceleration.
Acceleration A. Okay. I understand. Thank you, sir.
Now, in the case of M2, what is the direction of tension force?
Upward.
Rightward.
Up the inclined plane. Okay. Then after, in the case of M1 or with respect to M1, what is the direction of tension force? Away from the body along the string. So leftwards. Therefore, write down the dynamic equations. In the case of M2, what is the dynamic equation? In the case of-
M2g sine theta minus t.
Perfect. M2g sine theta minus t is a resultant force. Resultant force means mass into acceleration, that is M2a. Then after, in the case of M1 block, along the direction of motion, how many driving forces are acting?
One.
Only. So therefore, in the case of M1, what is the resultant force? That is
T.
the resultant force means mass into acceleration. So even, for example, if we add both equations, minus t plus t cancel out. Minus t plus t cancel out. See left side what we have, only M2g
We will
sine
get
theta.
acceleration.
Okay? And by adding them, M1a plus M2a. So by simplifying them, we get the same equation or not?
Yes.
Right on, next one.
It is ideal, no? String, so tension force is same.
Yes. Completed? Note it down.
Yes, sir.
Next question. For example, this angle, let it be theta 1, or this angle, let it be theta 2, and we have a fixed pulley, and this block mass M1 is connected to the block mass M2. So for example here, just assumption, if M2 block is sliding down the inclined plane with acceleration A. If M2 block sliding down the inclined plane. Then what about M1 block? It will move up the inclined plane. So here, how to find acceleration by using short trick? First of all, here M2 is the mass. So it is weight M2g vertically downwards. Now you please answer, this weight component is cos theta component or sin theta component?
Cos theta.
Cos theta. So it is M2g cos theta. Then after, this component is M2g sin theta. M2g sin theta. In the same way here, it is M1g weight vertically downwards. Now this component is
M1g sin theta.
M1g cos theta, and this component is M1g sin theta. It is M1g sin theta. Now just to guess what is the acceleration. And one more thing here, this block M2, the motion is along the inclined plane. This block M2 motion along the inclined plane. This block motion also along the inclined plane. So this motion along the inclined plane, this block motion also along the inclined plane. So along the inclined plane, weights or weight components we have to consider. Okay, so this M2g sin theta we have to consider or not?
We have to
Yes,
consider.
sir.
Yes.
With a positive sign.
Positive,
So,
Positive sign.
do one thing, this angle theta 2 now, so it is sin theta 2 cos theta 2. This angle theta 1, so M1g cos theta 1 and sin theta 1. So theta 2, so M2g cos theta 2, M2g sin theta 2. This angle theta 1, so M1g cos theta 1, M1g sin theta 1. So you please answer. To find the acceleration,
M2g sin theta.
M2g sin theta 2 minus
M1g sin theta
sin
1
theta
upon
1
M1 plus M2.
Upon M1 plus M2.
perfect. Upon M1 plus M2, the sum of the masses. And write down dynamic equation also. With respect to M2, what is the direction of tension force? Up the inclined plane, down the inclined plane?
Up.
Up the inclined plane. So it is tension force. Then after, in the case of M1, what is the direction of tension force?
Up.
Up the inclined plane, correct. Now in the case of M2 block, so what is the dynamic equation is?
M2g sin theta 2 minus t.
M2g sin theta 2 minus t is a resultant force. Resultant force means mass into acceleration. So that is M2. Then after, in the case of M1 block, what is the dynamic equation? Resultant force is
T minus M1g sin theta 1.
M1g sin theta 1 is a resultant force. Resultant force means mass into acceleration. That is M1a. So even though, for example, if we add both equations, minus t plus t cancel out, so we have M2g sin theta 2 minus
Same as
M1g sin theta
acceleration.
1, same as acceleration. Done?
1 minute.
Right done? Next one.
1 minute, please.
Yeah, right down. Next question. So this is block mass M2 and this block mass M1. It is moving downwards with the acceleration A. Now M2 will move right side with the acceleration A. So here it is M1g, its weight. Then after it is M2g, its weight. Now how to find the acceleration? So to find the acceleration M1g, we have to consider or not?
Yes.
Positive M1g, negative M1g.
Positive.
Positive, perfect. Then after M2G, we have to consider or
No.
not to consider?
No, not, do not.
Why?
No.
Because? Why? Because the
It is
motion is
balanced.
horizontal. The motion is
Downward
horizontal.
motion is balanced.
So therefore, only M1G we have to consider upon sum of the masses, M1 plus M2. So that is the acceleration. So in the case of M1, what is the direction of tension force T?
Upwards.
Upwards.
In the case of M2, what is the direction of tension?
Rightwards.
Rightwards. Therefore, you write down the dynamic equation for M1. For M1, so moving
M1A
downwards.
equals M1G minus T.
So resultant force is M1G minus T. Resultant force means mass into acceleration. So M1A. In the case of the block M2, so what is the drive? How many driving forces are present?
1.
1. That is tension force. So here, in the case of M2, the resultant force is only one driving force, that is T. Resultant force means mass into acceleration, that is M2.
Sir, why M1G positive?
Why M1G positive? Huh? See, along the direction of motion, this weight is present or not?
Yes.
So along the direction of motion, weight is present means positive or negative?
Right.
Right down. Next one.
1 minute, sir.
Sir, the next is 7th question, right?
I don't know the number. Okay.
Yes, 7th question.
Okay.
So here, for example, here we have a fixed pulley. This block mass M2 and this block mass M1. For example, moving down with acceleration A. And here we have another block mass M3. So for example, if M1 is moving down, what about M2 block? Will move to right side. And M3 block will move upwards. So here M1, M2 connected by a string. M1, M2 connected by a string, tension force T1. M2, M3 are connected by a different string, so tension force T2. So total here, how many unknowns we have? 3 unknowns. Acceleration, T1, T2. To find the 3 unknowns, we require 3 equations, correct? And how to get 3 equations? For M1 dynamic equation, M2 dynamic equation, M3 dynamic equation. So 3 dynamic equations, so 3 unknowns, we can simplify it. Okay, so that is the process we have to follow. So it is M1G, its weight. Then after, it is M2G, its weight. Then after, it is M3G, its weight. Now you follow the short trick to find acceleration. So M1G we have to consider or not?
Yes, plus M1G.
Perfect, plus M1G. Then after, what about M2G?
We don't have to consider.
Perfect. And M3G we have to consider
Negative.
Negative.
Negative, minus M3G. So why negative? Because so this M3G presents opposite to direction of motion. So direction of motion upwards, but it is downwards. This weight is present opposite to direction of motion, so negative. Upon in denominator, same thing, sum of the masses, M1 plus M2 plus M3. Then after, so here free body diagram of each and every block. With respect to M1, what is the direction of tension force T1 is? Upwards. And for the block M2, what is the T1 direction? For the block M2, T1 direction.
Leftwards. Rightwards.
Rightwards. Then after, for the block M2, what is the T2 direction? For the block M2, T2 direction.
Leftwards.
Leftwards. Then for the block M3, what is the tension force? Upwards.
Upwards.
So now we have the directions. write down the dynamic equations. First of all, in the case of M1 block, so what is the dynamic equation? Resultant force is M1G
minus T1.
M1G minus T1 is a resultant force. A resultant force means mass into acceleration. That is M1A. Then after, in the case of M2, see here, T1, T2, two tensional forces are present, but see the direction of motion. Direction of motion.
T1 minus T2.
T1 minus
Perfect.
T2.
So T1 minus T2 is a resultant force. T1 minus T2 is a resultant force. A resultant force means mass into acceleration. That is M2A. Then after, in the case of M3 block, moving upwards. So what is the dynamic equation?
T2 minus
T2 minus
T2 minus M3G. Resultant force means mass into acceleration. So M3A. So think logically. So here, if we add the three equations, minus T1 plus T1 cancel out. Minus T2 plus T2 cancel out. So what we left with only M1G
Same
minus
as
M3G. M1G minus M3G. So same as acceleration. Over.
One.
Yes, sir.
Sir, in this question, we have to find acceleration T1 and T2, right?
Correct. Acceleration T1 and T2. Okay. So first of all, do one thing. By using short trick, straight away we can find out acceleration. Okay. To find a T1 value, T2 value, you take down any one of the dynamic equation. We can find T1 and T2 values. Okay. Next question. For example, it is a fixed pulley. This block mass capital M, and here same thing, the mass capital M. Okay, same mass is capital M, but here we kept another small block small m. So we kept another block small m. The question is find normal force acting on okay small m. Find a normal force acting on small m due to capital M block. So we are finding normal force acting on small m block due to capital M block. So you please answer here. In this case, right side is a heavier, correct? Right side part is a heavier. So if it is a heavier, it will move downwards. If it is moving downwards, fixed pulley and this part will move upwards with the same magnitude of acceleration. Therefore, what is the short trick to find acceleration? In this case, small m and capital M. So what is the total weight in downward direction is total weight in downward direction, capital M plus small m into G. And here it is capital M G. So by using short trick, let us find out the acceleration. So first of all, this weight we have to consider, correct? This weight we have to consider, but positive or negative sign? Positive. So capital M plus small m into G, positive. Then after this mg we have to consider or not?
Yes.
Positive or negative?
Negative.
Negative. So minus mg upon in denominator sum of the masses. So whatever sum of the masses totally? 2 capital M plus small m is the sum of the masses. In the numerator, so here we have capital Mg, okay, capital Mg minus Mg, they cancel out. Therefore, what is the acceleration equation finally? What is the numerator? Small mg upon 2m plus n. It is about acceleration of each block. Acceleration of each block. But the question is, we have to find a normal force. We have to find normal force acting on a small m block. So let us draw free body diagram of small m block. I'm drawing free body diagram of small m. In the case of small m block, what is the direction of motion? Moving downwards.
Downwards.
So its direction of motion downwards. Then after small m is a mass we are taking. So what about its weight mg downwards? Then after, so what is the direction of normal force acting on small m due to capital
Upwards.
M?
Upward.
Perfect. So normal force upwards. Therefore, do we have any more forces acting on small m block?
No.
No. Okay. So why? Because this string is connected to capital M block, but not to small m block. String is connected to capital M block, but not to small m block. Therefore, what is the dynamic equation for this block?
Mg minus n.
So mg minus n is the resultant force. Resultant force means mass into acceleration, m into u. So by modifying this equation, we get normal force equal to what we get, mg minus mu. So already here we have acceleration. This acceleration equation, so we can take it here and we can find out n value. Now this is the process we have to follow to find acceleration and normal force. So generally what we have to do it, this acceleration we have to write in this equation and we can simplify it. By simplifying, we can find out normal force. Yeah, note down fast.
Done, sir.
Just a question. In the next question, so it is a fixed pulley. It is a fixed pulley, and here this block mass m1.
Sir,
Please.
in previous question you drawn arrow to show something. What you want to show?
That acceleration we have to keep in the normal force equation. Okay.
Okay, sir. Yes.
Draw the figure. The question is, in the given figure, find an expression, in terms of, m1, m2, m3. So we have to find an equation or an expression in terms of m1, m2, m3 if the block m1 is at rest. If the block m1 is at rest. In the question, only m1 block is at rest position. It is not mentioned that m2, m3 are at rest position. It's not mentioned. Only m1 block at rest position. So here m2, m3 block, okay, so maybe they are in motion. For example, if one is moving downwards, other one will move upwards, correct? Like this. I have a question. Now, you consider only this m2, m3 part. So you forget about this one. You take only m2, m3 part. Now this is similar to which question of, so we are doing the questions. So M2, M3, it is similar to which question? You refer the first question, what we done it. You refer the first question, what we done it. Then according to first question, what is the value of T tension force in the string?
2m2 m3g upon m2 plus m3.
Perfect. So this tension force is 2 m2 m3 g upon m2 plus m3. Okay, if it is not clear, we will do in detail. So how this formula, how it comes? Is it clear? Can I do it in detailed derivation part? You take, for example, in this question, you take this portion. It is as it is of the first question, what we done in this concept, finding tension force and acceleration. You refer the first question is similar to this portion. In the first question, what is the tension force? We got it 2 m1 m2 g upon m1 plus m2, we got it in the first question. But in the place of m1 m2, here we have m2 m3, nothing else. Therefore, T equal to 2 m2 m3 g upon m2 plus m3. Is it clear?
Yes,
This
sir.
point? Okay.
We are
No.
assuming that M3 goes down and M2 goes up, right?
That's up to you. You take M2 downwards, M3 upwards. This tension force, it doesn't change. Okay.
Yes, sir.
Sir, but in the first question, the pulley was fixed, and here the pulley is movable, so that will not affect the tension force, no?
Okay. See, in this case, for example, if I'm writing M3 block, okay, M3 block direction of motion, it is M3G and T tension force, correct? M3G and T tension force and acceleration. Is it clear?
Yes, sir.
Now, what is the dynamic equation we get it? For this block, what is the dynamic equation?
M3 minus T.
M3G minus T.
M3G minus T equal to M3A. For this block, what is the dynamic equation?
T minus M2G.
T
By
minus
adding them, by simplifying, we get the same T value. Okay. So therefore, now I'm taking this pulley. For this pulley, let us draw free body diagram. For this pulley, let us draw free body diagram. For this pulley, this side, what is the direction of tension force? For
Downward.
this pulley, downwards. Perfect. It is T tension force. In the same way, for this pulley, left side, what is the direction of tension force?
Downward.
Downward. Perfect. Okay. So here, with respect to pulley, tension force downwards. With respect to pulley, tension force downwards. Therefore, here, in this case, you please answer. So in this string, what is the tension force will be? First of all, what is the direction of tension force? For this pulley, what is the direction?
Upwards.
upwards.
But what is the value of this tension force? T or 2T or 3T?
2T.
2T. Why 2T? Ideal. So it is an ideal pulley. In the case of ideal pulley, resultant force 0, my forces are balanced. So it is 2T. So it should be also 2T. Is the logic clear?
Yes, sir.
Okay. So that means finally here in this string, what is the tension force we got it?
2T.
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 Perfect. In this string, the tension force is 2T. So now with respect to M1 block, what is the direction of this tension force? For M1 block,
Upwards.
upwards. And for M1, what is the weight direction?
Downward. M1G.
M1G. And in the question, the block M1 is at rest position. M1 is at a rest position. That means these two forces are
Balanced.
balanced. So therefore 2T is balanced by M1G. So 2T, we have already T value. So 2T becomes what we get 4 M2 M3 G upon M2 plus M3. So we have 2T value. So you multiply with 2. So 4 M2 M3 G upon M2 plus M3 equal to on right hand side M1G. So G cancel out. G value cancel out. Do one thing. This is 4. You bring to right hand side. 4 to right hand side. Then what we get on left hand? That is M2 M3 upon M2 plus M3 equal to, there's a 4 to right hand sides, we get M1 upon 4. Then after, do one thing, take the reciprocal on both sides. Taking reciprocal on both sides. By taking reciprocal, so you know reciprocal means numerator goes to denominator, denominator goes to numerator. So by taking its reciprocal, we get M2 plus M3 upon M2 M3 equal to, and what about its reciprocal? Its reciprocal
4 by M1.
4 by M1. Then after, left side you do separation. Left side do separation. So M2 upon M2 upon M2 M3 plus, now this separation, M3 upon M2 M3 equal to, on right hand side, 4 upon M1. Therefore, so here M2 M2 cancel out, M3 M3 cancel out. So after cancellation, so here M2 M2 cancel out, M3 M3 cancel out. After cancellation, what is the final equation? We have 1 upon M3 plus, and M3 M3 already cancelled out, we have 1 upon M2 equal to, on right hand side, 4 upon M1. This is the final expression in terms of M1, M2, M3.
So the tension force that you took on the right side of the pulley,
Okay.
it was with respect to pulley, no?
With respect to pulley. With respect to pulley, away from the pulley, away from the
Yes,
pulley,
yes.
away from the
Because
pulley.
from block it would be different, no? So I got it.
Correct. Perfect. So in the next lecture, we will do the same type of questions, finding acceleration, finding tension force, but more complex questions. Okay, these are the basics of pulley block system. But in the next lecture, we will do principle of virtual work, the very complex questions we will do it. Okay.
Okay, sir.
Bye. Bye, sir. Thank you,
Thank
sir.
you, sir.
Thank
Bye,
you,
sir.
sir.
Goodbye, sir.
So I wonder.
Sir,
Please.
I understood what you did in after you got 2t, but could you just repeat it? Like you got 2t on the right, then
This is 2T, the same string now.
yes,
So in the case
tension
of
force is constant.
so tension force is constant. So here, what is the tension force? 2T. The same tension force 2T also present over here. Correct?
Yes, sir. Yes. I just want. Thank you, sir.
So
It is same string, so tension force T, and it is the same string, so tension force 2T. Okay.
Okay, sir. Thank you.
Please.
Sir, I
So-
did not understand the 2 columns you have made. No, that right side column, last step.
Okay.
Yes, sir.
This one.
Cutting, I did not understand.
So we are doing separation. Separation M2 upon M2 M3.
Okay,
This
sir.
separation.
Got it.
So I have one more doubt.
Please.
So that t value which you gave, that will remain the same even if the pulley is fixed or it is movable pulley.
Why? Because here,
If we add
Because-
those equations, the value will be same.
in this case, resultant force is what? Resultant force acting on the pulley. 0, na?
Yes, ideal pulley.
Okay. So in this case, so it is the ideal pulley, so resultant force 0. So even though here this pulley is moving up or moving down, so in this case, resultant force acting on it is 0. Resultant force acting on it is 0. If resultant force 0, that is 2T is balanced by, it is a 2T. Is it clear first of all?
Yes, sir.
Then after, in this case, for this block, if write down the dynamic equation, we get the same thing. This is the
Okay,
moving
sir.
pulley or a fixed pulley, we get the same equation. By writing it's a dynamic equation, it's a dynamic equation.
Okay, sir. Thank you so much. Bye, sir.
Bye.